Hello, welcome to my YouTube channel. My name is Onyedike Akachuku, aka Onyimas, and I love to tutor. In this video, I'll be breaking down indices from the top to the bottom. This video will make a lot of sense, so please like, comment, and share this video with someone. Also subscribe to my channel and do not forget to turn on your notification bell so as to get my new video alerts. So relax now and enjoy the class. First things first, let's look at the definition of indices. Let's look at this definition. It's right there on your screen. You can look at it along with me. Indices or powers is one form of writing numbers. Now, there are many forms of writing numbers, okay? Indices or powers, the use of powers, okay? It's another form of writing numbers, rewriting numbers, where we shorten and show a number multiplied repeatedly by itself, and the number of times or places the number is multiplied. Okay, so we're going to look at an example to clearly understand what this definition is all about. So it's a form of writing numbers where we shorten and show a number multiplied repeatedly by itself. So let's look at this example. We have a number here. And what's the number? The number is 3. And this number is multiplied repeatedly by itself. So now instead of leaving this multiplication this way, okay, we want to rewrite it in another way. We're not changing the meaning, we just want to rewrite it in another form, which is the index form, okay? So this number is multiplied repeatedly by itself for a number of times, okay? So the number here is what? The number here is 3, and the number of times is multiplied by itself is, let's count it, 1, 2, 3, and 4. So we have that the number is 3 raised to the power 4. So 3 is the number, and 4 is the number of times that number is multiplied repeatedly by itself. Let's take a look at another example so we can understand even more better. So here we have the number 2. The number here is 2. And what about this 2? This 2 is multiplied repeatedly by itself, again, for a number of times. So let's count the number of times: 1, 2, 3, 4, and 5. So we have that the number is 2 multiplied repeatedly by itself 5 times. So here it is. The number is 2, and the number of times is multiplied by itself is 5. Hope you're getting this. So now, look at this point. Indices can be done with letters as well as numbers. So in the above two examples, we looked at numbers. So there are cases where you can have numbers instead of you can have letters, instead of numbers. So we can have, let's say, A times A, okay? And you're expected to write this in index form. So it's just the letter A multiplied repeatedly by itself. So the letter here is A, and the number of times is multiplied repeatedly is 1, 2, and 3. So, and we write it as this. So it's A to the power 3. Okay, so we have shown that indices can be done with letters as well as numbers. So it's not only numbers that you will be seeing as we move on. So this other point says indices can apply to integers. Indices can apply to, now at this point, I'm going to let you understand that indices, of course, you saw it in our definition that either you call it indices or you call it powers, okay? So it's about the powers. Indices is just about powers, okay? So it can be the power of a number or a letter can be an integer. It can be positive, like you can have your negative numbers such as -1, -2, -3, or you can have your positive integers such as 3, such as 4, or even 5. Okay, those are positive integers. You can also have your indices or your powers as fractions. You can have something like 2 over 5 or 1 over 2 or whatever fraction. Just a fraction having a numerator and a denominator. You can have your powers as a fraction. It can be a negative fraction. You can have a negative fraction like minus 1 over 2 instead of just 1 over 2. Okay, and you can also have powers as decimals. You can have 0.15, you can have 0.25. Okay, these are all the forms that powers can come in. Okay, so let's look at the next point. The next point says the word index and power are used interchangeably. Indices is the plural of index. Okay, so when you hear me say index, it means I'm talking about just one power. Okay, so indices and powers, index and power can be used interchangeably. So indices, if it's either you're saying indices or you're saying powers. Okay, so now that is a very important point to note. The number that is multiplied repeatedly is the base, while the number of times the number is repeated is called the number of times the number is repeated is called the power or the index. We're going to express this. All right, so the number that is multiplied repeated. So supposing we have, let's use a letter this, supposing we have m such that we have that m times m times m. Okay, so what is this going to be in index form? The letter here is m, right? Multiplied, repeated by itself. How many times? 3 times. So this is saying to us, let me write it here so you can see it. This is m raised to the power 3. So this is saying to us that the number that is multiplied, it can be a letter, okay? For this case, it's a letter. The number that is multiplied repeatedly is the base. So this is saying this is m multiplied repeatedly here, okay? So is the base, while the number of times the number is repeated is called the power on the index. So it's 3 times that the number is repeated. So, and that's what we denoted here. So this is saying that this is the power, or you can call it the index. Okay. All right, so let's look at the above example with this understanding. Okay, in the examples we considered above, 3 raised to the power 4. In this case, 4 is the what? The power. And 3 is the base. All right, so similarly, in 2 raised to the power 5, we have that 5 is the power. 5 is the power and 2 is the base. Now, to solve expressions involving indices, we use rules known as the laws of indices. Now, it's very important that you note that these laws are very, very important. You need to have them at the tips of your fingers while solving questions revolving around indices. And at the end of this video, we're going to be solving a lot of questions that will be involving the application of these laws of indices. There are a lot of the laws of indices, so we'll be applying them. A particular question can, require you applying more than one law of indices. So it's very important you know all the laws so that at any point in time while solving a question, you can know which law to apply at a given time. All right, so let's look at the laws of indices. All right, the first law we're going to look at is the multiplication law. Okay, now let's look at what this law says. Here it is, what the law and the rule says. So this rule, read along with me. This rule tells us that if numbers or letters have the same basis and are multiplied together, then their indices or powers can be added together. So we're going to look at these definition with this expression here. Now we can see it's saying that if numbers, in this case we have letters, have the same basis. So this is a number and this is another number. Do they have the same basis? Yes. What are their bases? M. So if they have the same basis, it's established that they have the same basis. Then their indices, they have powers. Their powers are A and B. So what we can do with their powers is that we can add their powers together, which you're seeing here. This is the number and these are the powers added together. All right. So we're going to take an example to illustrate this so you'll understand it better. So let's see 2 raised to the power 3 times 2 raised to the power 4. Let's solve this and verify. So this, according to the multiplication law of indices, is saying that if the numbers have the same basis, looking at this, the numbers have the same basis, okay? So this is going to be 2. All right, and what do we do with their powers? We add their powers. Given that they are being multiplied together, we add their powers. So we have that 2 is raised to the power 3 plus 4, and this is equal to 2 raised to the power 3 plus 4 is what? 7. Okay, is 7. All right, now we can verify this to be sure that there's nothing wrong with this law, okay? So that you'll understand that these laws are tested and proven. Okay, so now this is, let's look at the 2 raised to the power 3. Let's look at the question originally, 2 raised to the power 4. Okay, so now this can be expressed as 2 times 2 times 2. And then with this connecting multiplication sign, and then this one can be expressed as 2 times 2 times 2 and times 2. So we're having a lot of 2's here, okay? And it's the same 2, the same number, okay? So we can write it in index form as the number here is 2. How many times is it multiplied together by itself? So we have 1, 2, 3, 4, 5, 6, and 7. So this is it, 2 raised to the power 7. You can see that we have verified the multiplication law, and we have gotten the same answer we got using the multiplication law. So this is the same with this, okay? So there's nothing wrong with the multiplication law. All right, let's move on to look at another law, the division law. And let's look at what it says. All right, this rule tells us that if numbers or letters that have the same base, now we hear again the same base, are dividing one another, then we are free at all times to subtract the power of the divisor from that of the dividend. Okay, so let me define what divisor means here. Okay, the divisor, the dividend is the number that is being divided, and it usually comes before the division sign. Okay, this number comes, so looking at this expression here, this is the dividend. It's coming before the division sign, and the divisor is the number that is dividing the other number, and it usually comes after the division sign, okay? And this is it. So here we can see that these numbers have the same basis. We have M and we have M, and these letters rather, they have the same basis. So what can we do with their powers? We subtract the power of the dividend, of the divisor from that of the dividend, and that's exactly what you see here. M raised to the power A minus B, okay? We're going to solve an example using this rule, and we're going to verify the example, okay? So we have, let's look at 3 raised to the power 5, 3 raised to the power 5 divided by 3 raised to the power 3, okay? We can see, now looking at this, you see that they have the same base, 3, 3, okay? So the number here is 3, and what do we do with their powers? So what's the power of the divisor? Is 3, and the power of the dividend is what? 5. So we're going to say 5 minus 3, and that is equal to that is equal to 3 raised to the power 5 minus 3 is 2, and this is equal to 9. This is equal to 9. Okay, so now we're going to verify this. Okay, so we have that the expression is 3 raised to the power 5 divided by 3 raised to the power 3. So 3 raised to the power 5, this is equal to 3 raised to the power 5 over 3 raised to the power 3. Okay, now expressing 3 raised to the power 5, we have, sorry, ignore this. We have that, we have 3 times 3 up to 5 times, right? 3 times 3 times 3 times 3 all over 3 raised to the power 3 is 3 times 3 up to 3 times. Okay, so we can cancel out, this can cancel out this, and this can cancel out this, and this can cancel out this. So we're left with 2 3's on top, and that's 3 times 3, which is equal to 9. So verifying with using this example, we can see that we got the same answer. Okay, so again, there is nothing wrong with the division law. You can feel free to apply it anytime you're dividing numbers that have the same basis and are dividing one another. Okay, so you may not need to start verifying. It will take you a lot of time to do so. So when you're solving questions in your exam, you just go straight to the point and apply the division rule. Let's look at another law. So the next is the power law. All right, let's look at its definition. Let's look at what the power law says. This is the definition. This is what it has to say. This rule tells us that when a number that is raised to a given power. Now, look at the expression here. This is a letter, okay? A number, it can be a number, it's a letter here, okay? So it's raised to a given power. The given power is m, usually in a bracket. Of course, you can see it's in a bracket. It's again raised to another power. It's again raised to another power, which is n. Then the two powers can be multiplied together. So it's equal to the number with the two powers multiplied together. So let's look at a raised to the power 4, a raised to the power 4, or raised to the power 3. Okay, and according to this power law, it says that it's the same thing as the number raised to the powers multiplied together. So we have that is 4 times 3, and this implies that a is equal to what? 12. 4 times 3 is 12. So let's verify this. So a raised to the power 4 all raised to the power 3 implies that we're multiplying what is inside this bracket repeatedly 3 times. So and that this implies we're verifying we're verifying the power law using this example now. So we have that a4 is multiplied by itself up to how many times? 3 times. So a4 again times a raised to the power 4, and it's equal to what? It's equal to a times a times a times a. That is for this one because we have 4 a's. Okay, all right, times for this one we have a times a times a times a. Okay, there's an a there. And then for this one, all right, then for this one we have it as a times a times a times a. So we have all a's now. Okay, the same number multiplied repeatedly. And then how many times? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have that the number 8 multiplied repeatedly by itself up to 12 times. All right, you can see that this is the same as what we got using the power law. All right, so the power law is tested and proven. You can always apply it. All right, let's look at the next law. All right, so this is the product power rule. We're going to look at the definition as always. We're going to look at it to see what it has to tell us. This rule tells us, read along with me, that if the product of several factors likely in a bracket, now looking at this product, this is a product, okay, of several factors. We have A times B times C. These can be multiplied together. It's raised to a given power, and the given power here is m. Then every factor in the bracket gets the power each. So you can see that A takes the power m, B takes the power m, and C takes the power m. Okay, so now, okay, there's a note here that says this rule is mostly applicable to letters or a combination of letters and a number. All right, let's take an example to illustrate this. So we have 2ab. So this is a combination of a number and two letters. 2ab raised to the power 3. Okay, so according to the product power law, it states that each of the factors take the power each. So 2 is taking the power 3, A is taking the power 3, and B is taking the power 3. So, and this is equal to 2 raised to the power 3, 2 times 2 times 2, and that is 8. So this is 8A raised to the power 3 and B raised to the power 3. Okay, so let's verify this. So with this product inside the bracket raised to the power 3, this implies that this thing inside this bracket should be multiplied by itself up to 3 times. So let's verify it. All right, so we have that this is equal to 2ab times 2ab times 2ab. All right, so we have 2 times a times b times 2 times a times b. This is for this, and this is for this. This is for this, and this is for this. Okay, and then we have times 2 times a times b. Okay, this is for this. All right, so now, so we have that there are like terms here. So we have 1, 2. We have how many 2's? 1, 2, 3, and that is 2 times 2 times 2. We're collecting the like terms now. Times there are a's. A times A times A. Look at the A's, 1, 2, and 3. And then we have the B's. B times one B times the other B times the last B. Okay, so 2 times 2 times 2 is what? 8. And then A raised to the power 3 and B raised to the power B multiplied repeatedly by itself. How many times? 3 times. So you can see that this is the same as the value we got here. All right, let's go on to the next rule. Okay, here we are at the zero power rule. Let's look at what this rule says. Look at what it says. This rule tells us that any number or quantity apart from 0, any number or quantity apart from 0 that is raised to the power 0 is equal to 1. It says any number, and any number is any number. So any quantity whatsoever raised to the power 0 is equal to 1. 1 million raised to the power 0 is equal to 1. 10,000 raised to the power 0 is equal to 1. 1 minus 3 raised to the power 0. So it could be a negative number. Raised to the power 0 is equal to 1. 67, a fraction, 67 over 144 raised to the power 0 is equal to 1. BE, so it could be a letter, raised to the power 0 is equal to 1. Any quantity whatsoever. 4B, a product, raised to the power 0 is equal to 1. So any quantity, any number, any letter raised to the power 0 is equal to 1. So anytime you're solving and you come to the point where something is raised to the power 0, the result is always 1. Let's look at the next. Now, at this point, I would like to state that after we have looked at these laws, we're going to solve a lot of questions that will help us to understand the law better, will help us to appreciate this law. So do not forget, the next video that is going to follow this one is the one that will contain the solved questions. We'll be doing it together, solving the questions on indices, okay, applying the laws of indices and solving these questions. All right, so let's move on to the next rule. As you can see on your screen, negative indices, or you can call it negative powers. Okay, so let's look at what this rule tells us. Let's look at what the rule says. This is what the rule says. This rule tells us that any number or quantity raised to a negative power or index is always equal to the reciprocal of that same number or quantity, but the negative sign before the power disappears, making the power positive. Now, you really need to take this slowly so you can internalize it. So if a number is raised to a negative power, as in this expression, b is raised to the negative power minus a, so is the same as 1 over b raised to the power a. Let me at this point define reciprocal. The reciprocal of a number or quantity is 1 divided by that number. Okay, the reciprocal of a number or quantity is 1 divided by that number or quantity. For example, if we have 5 and we're asked to find the reciprocal of 5, the reciprocal of 5 is equal to 1 divided by the number 5. So if I have 4, the reciprocal of 4 is 1 divided by 4. The reciprocal of minus 3 is 1 divided by the number minus 3. So assuming you have the number, this is a number 1 over 5, and you're asked to find the reciprocal. Of course, it's 1 over, the reciprocal of a number is 1 over the number, so 1 divided by the number. So this is the number we have, 1 over 5, and then the reciprocal will be 1 over 5, okay? And this is the same thing as 1 divided by 1 over 5. We can't work with the division sign, okay? We have to change it to minus. So this is equal to 1 times, at this point we invert the fraction, so it will be 5 over 1, and this is equal to 5. So you can see that the reciprocal of this fraction is the same thing as 5, okay? It's the same thing as 5. All right, so the reciprocal of a fraction is the fraction inverted, okay? You swap, like the reciprocal of, let's take another fraction, 1 over 4 will be 4 over 1. Okay, that's what you do for fractions. But for other numbers, it's 1 over the number. Okay, so now this rule tells us that, okay, that if a number is raised to a negative power, like b is raised to a negative power a, and is the same thing as the reciprocal of the number, still raised to the same power, but the negative sign disappears. So you can see that there's no negative sign before a here. There's no negative sign, okay? So we're going to take an example to illustrate this. All right, let's look at 4 raised to a negative index minus 3. Okay, it's the same thing as, okay, according to the rule on negative indices. So we're going to take the reciprocal of this 4 raised to power minus 3. So it's going to be 1 over the number 4, right? Raised to the same power, but the negative sign disappears. So, and this is equal to 1 over 4 raised to the power 3 is 4 multiplied repeatedly by itself into 3 places, and this is equal to 1 over 4 times 4 times 4 is 64. Okay, let's take another example. Y raised to the power minus 2. The rule on negative indices says that we take the reciprocal of the number 1 over y. That's the reciprocal of the number of the alphabet here, letter here. So raised to the same power, but the negative sign disappears. Okay, all right, so this is what this is. Let's look at another example. 3 raised to the power minus 3. Now you can try this one. You can pause the video and try this one. So this is 1 over what? 3 raised to the same power, but without the negative sign. And this is equal to 1 over 3. 3 raised to the power 3 is 3 multiplied repeatedly 3 times. 3 times 3 times 3. And that is 1 over 3 times 3 times 3 is 27. So that is it. So there are so many examples on this one, so many examples you can do. So you can look into your textbooks and get examples on this and try your hands on them. Meanwhile, after this video, I'm going to do another video where we're going to solve many questions that will require you applying the laws of indices. You can apply more than one law of indices on a particular question. Let's move on to the next law. Okay, so this law says, this law is about fractional indices, fractional powers. Okay, you know what fractions are. All right, so you can see that this number m is raised to a fractional power a over b. Any number in this form, a over b, is a fraction, right? So let's look at what this rule says. This is what the rule says. Let's read along. This rule tells us that if a number is raised to a fractional power, then the denominator is regarded as a root, like square roots, cube roots, fourth root, fifth root, etc. roots, while the numerator is regarded as a power or index. This is very, very simple. Take the numerator as the power and then the denominator as the root. Okay. So let's take some examples to illustrate this. So let's look at 16 raised to the power 3 over 4. So you can see that the power here is a fraction. So this rule is saying that the numerator is regarded as the power and the denominator is regarded as the root. So we're going to write this question in this form, okay? All right, so 16 raised to the power 3 over 4 is equal to, taking the denominator as the root, we have the fourth root, okay? The fourth root of the number 16, all raised to the power, the numerator as the power, all raised to the power 3. So in this, we are going to look for a number, that's one particular number we're going to multiply 4 times to give us 16. And what is that number? Can you guess? Okay, the number is 2. The number is 2. So we have that fourth root. So 2 is that number that you multiply repeatedly 4 times to give you 16. All right, so you can see how we replace 16. 2 raised to the power 4 is the same thing as 16. So now these 4 cancels this root. Okay, so we're now left with 2 raised to the power 3, and which is equal to what? 8. All right, let's take another example. Another example is 8 raised to the power 5 over 3. So we take this as the power, and we take the denominator as the root. So this is going to be equal to third root of 8, all raised to the power 5. All raised to the power 5. And so for what is in the bracket, we're going to look for a number that will multiply 3 times to give us 8. So, and what is that number? Third root, 2 raised to the power 3 is the same thing as 8. Okay, it must be, if you want to cancel out the root, whatever you're having as the power here must be the same. Okay, so all raised to the power, we're still retaining our power 5 here. So all raised to the power 5. So this power is cancelling out this root, and this is equal to 2. We're still retaining our power 2 raised to the power 5. And 2 raised to the power 5 is what? 32. You can verify that using your calculator or just solving it by the hand. All right. All right, so this is pretty much most of the rules. I don't think there's any other rule. Okay, so this is pretty much most of the rules that you need in solving questions, in solving expressions involving indices. All right, so but there's something else that we need to look at where you have decimal bases or decimal powers. Okay, now there can be cases where your base, you already know what base is, the number that is being multiplied repeatedly, right? And then you know what your powers are. That's your indices. Let's look at what is being said here. Decimal power or base. Let's read along with me. If the power or base of any expression is in decimal form, you can first convert such decimals to fractions to help you solve easily. Okay, now I'm going to take a lot of questions, a lot of examples on this so that it can help you understand what is being said. Sometimes the base can be in a decimal form, or the power can be the decimal. So the simplest way to solve questions that are like that, or expressions that are like that, is to convert those decimals to fractions. Okay, of course, you know fractions are opposite of decimals, so you just convert it, and that's the only way you can conveniently solve such questions. All right, so let's look at an example. 0.027 raised to the power minus 1 over 3. Okay, so how do we solve this? Now you can see that the what we have in decimal form is the base, so we're going to convert it to a fraction. Okay, so first let's convert this to a fraction. Okay, 0.027 is the same thing as, first of all, if you want to convert this to a decimal, okay, you start from the first significant figure. The first significant figure is the first non-zero digit in this decimal number. Okay, the first is 2. Okay, so we start from 2, and we write it down to the last number. So we have 27 over, and then we check the place value of the last digit. Okay, this is tenth. This is the place value of this is tenth. This is 100, and this is 1,000. Okay, so this is going to be 27 over 1,000. So we're going to replace what is inside here with 27 over 1,000. So we are writing that as 27 over 1,000. Okay, all raised to the power minus 1 over 3. All right, so you can see that you have a negative power here. So what did we say about negative powers? What did we say about negative indices? Okay, we said if a number is raised to a negative index, we take the reciprocal of the number. Which number is raised to a negative index here? Is the number in this bracket, and it appears to be a fraction. And we said something about the reciprocal of fractions. We said you invert the fraction. So if we're going to invert this fraction and take away, we're going to take the reciprocal of this fraction here, and the negative sign disappears. So it's going to be the denominator coming up. This is what you do for fractions, and the numerator coming down. So we change their positions. So we have 1000 over 27. So this is the reciprocal of this number, okay? And because we have taken the reciprocal, we're going to do away with the negative sign. So it's still raised to the power 1 over 3. This is what we have now. So this is a fractional power, okay? We're left with this fractional power. And what did we say about fractional indexes? The numerator is taken as the power, and the denominator is taken as the root. So we have that this up here is equal to third root, okay? It's going to be third root of 1000 over 27, all raised to the power what? All raised to the power 1. And of course, you know that anything raised to the power 1 is still that thing, okay? So this power 1 is very negligible. We're not going to make use of it. All right, so now we ask ourselves, what number do we multiply 3 times to give us 1000? And what other number can we multiply 3 times to give us 27? Now, for the case of 1000 up here, we have that 10 multiplied 3 times will give us now why are we saying 3 times? Because the root is 3. Okay, so we have that 10 raised to the power 3. It's 1000, and 3 raised to the power 3 is 27. Okay, and these two powers are the same. Okay, so we have third root of 10 over 3 raised to the power 3. Okay, we have done away with the power 1. Okay, it's nothing. So this cancels out this. All right, so we're left with 10 over 3. We're left with 10 over 3. And that is, if you reduce it further, it's going to be 3 whole number, 1 over 3. That's it. Let's look at another example form. So we have 16 over 25, all raised to the power 1.5. Okay, all right, so is the power here that is in decimal form. So we're going to convert the power, okay, to a fraction. So 1.5 is the same thing as, first we check the first significant figure here. The first non-zero digit is 1. So we start from there to write 115. Okay, so we connect the numbers together. 15 over, now we check the place value of the last digit. Okay, the place value of the last digit of the last decimal digit. Okay, the place value of the last number after the decimal point, and it's 5, and the place value is what? 10. So this is 15 over 10. Okay, and we can reduce this further to be 5 can go to give us 3, and 5 can go here to give us 2. So we have that this is 3 over 2. Okay, so we're replacing it up there. So instead of this, what we have, this is now equal to 16 over 25 raised to the power 1.5 is perfectly the same thing as 16 over 25 raised to the power 3 over 2. Okay, so And remember what we said, this is a fractional power, okay? We have a fraction here as the power. And remember what we said about fractional powers. The numerator is regarded as the power, while the denominator is regarded as the root. So 3 is our power here, 3 is the power here, and y2 is the denominator and is taken as the root. So we're doing square root, okay? Square root of this number, okay? This is the number. So square root of 16 over 25. We don't write 2 here, okay? For square root, we don't write. This sign alone is square root. All right, all raised to the power what? The power is 3. So we have 3. All right, so which number can we multiply 2 times to give us 16? And which number can we multiply 2 times to give us 25? All right, for 16, we have 4. 4 times 4. So, and for 5, we have, for 25, we have 5. If you multiply 5 2 times, so this is 2 times, and we still have the square root. This is 2 here. There's a 2 here, but we don't write it. All right, still all raised to the power what? All raised to the power 3. Okay, so these 2 cancels out this square root, and then we're left with 4 over 5 all raised to the power 3. So each of them takes their power. So this 4 takes the power 3, and the 5 takes the power 3. Remember the product power rule. Okay, you can rewind back to look at it again. So 4 raised to the power 3 is what? Is 64. Is 64, and 5 raised to the power 3, that's 5 times 5 times 5 is 125. All right, that's it for this. So we're taking more examples. Let's look at another example. Next is 0.01 raised to the power 3. Now, in this case, is the base that is in decimal form. Okay, so we try to convert the base to a fraction. So 0.01 is the same thing as, so we check for the first significant, we start writing the number, the numerator from the first significant number. So that's the first non-zero digit. Okay, so from here we have that is 1. All right, so it's only 1 we have. Okay, so 1 is the first one, and 1 is the first and the last. So now we check for the place value of the last decimal number. Okay, the decimal number. All right, so we have that the first place value is 10th, and the second place value is what? 100. So we're going to have 1 over 100. So this 0.01 is the same thing as 1 over 100. All right, so we have 1 over 100 all raised to the power 3. So we have written this as this. Okay, so we have that this is the same thing as so each of them takes the power. So this is 1 over 1 raised to the power 3, and 100 takes the power 3, and so this is equal to 1 raised to the power 3 is 1, and 100 raised to the power 3, 1 million. Okay, it's the same thing as 1 million. Let's look at another question. We're still solving questions revolving around decimal power or bases, okay? So the next question is 0.25 raised to the power minus 1 over 2. All right, we can see that the base here is in decimal form. So we first convert it to a fraction. So this is equal to, the first significant figure is 2. We keep writing 2 and 5 are the significant figures here. So 25 over what is the last decimal number here is 5, and the place value is what? This is tenth and this is 100. So we have 25 over 100. Okay, so we can reduce this further. 25 can divide to give us 1. 25 can divide this also to give us 4. So we have that this is the same thing as 1 over 4. So we're writing it as 1 over 4 raised to the power minus 1 over 2. Okay, at this point we have to remove this negative sign before the power. So how do we remove it? By taking the reciprocal of the number. Okay, and the number here is 1 over 4. It's a fraction. Taking the reciprocal of a fraction is inverting the fraction. The numerator becomes the denominator and the denominator becomes the numerator. So this is going to be 4, okay? 4 over 1 raised to the power, the same power, but without the negative sign because we have taken the reciprocal. So 4 over 1 is the same thing as 4. 4 raised to the power half. Okay, so this is regarded as the power. This is regarded as the power, and this is regarded as the root. So we're going to take the second root of, so this is equal to square root of 4, okay? Raised to the power 1, we don't need to write it, okay? Raised to the power 1. All right, let's write it. So what number can we multiply 2 times to give us 4? The number is 2, right? So 2 raised to the power 2 will give us 4. All right, so 2 can cancel out the root. The power 2 can cancel, and we have 2 raised to the power 1, which is equal to 2. One last thing to consider under these indices before we tie it up is exponential expressions, exponential equations. Okay, now let's look at these let's read this and find out what this is all about. When the power or index in a function is unknown, the function is called an exponential function. Meanwhile, there are cases where the unknown is the base, not the power. The best approach to use for solving these kinds of equation is to make both sides of the equation to be in the same base. All right, we're going to solve just one question to illustrate this. If you want to get more questions solved under these exponential equations or expressions, whatever you may call it, you can find them on my Instagram handle, which I'm going to put after this video, okay? And you can also find them on YouTube. I think I'm going to put them on YouTube. A lot of questions solved under exponential equations. And do you know that most of the questions I solved can be solved using your calculator? Okay, so please don't stop watching my videos. You're going to learn a lot and you're going to benefit from the easiest way to solve problems. All right, so let's look at this question. 4 raised to the power x, 4 raised to the power x is equal to 1 over 1024. Now this let's read this definition again. When the power or index in a function is unknown, as you can see, the power here is unknown, and this is an equation. You can see the equal to sign, okay? It is called an exponential function or equation. So this is an exponential equation. Meanwhile, there are cases where the unknown is the base, not the power. Now look at how the best approach you have been given to solve questions on exponential functions or equations. The best approach is to to use for solving these kinds of equation is to make both sides of the equation to be in the same base. So now we're going to try to make this to be in the same base with make both sides of the equation to be in the same base. So here we have 4 raised to power x. Is there any way we can make this side to have the same base with this one? Okay, 4 can further be reduced to 2, but let's see if we can reduce 1024 to 4 base 4. All right, so we have that one. We have 1 over 1024. Let's try to find out. 4 times 4 is 16. 16 times 4 is 64. 64 times 4 is 256, and 256 times 4 is equal to 1024, and that's 5 fours. Okay, so 5 fours multiplied repeatedly will give us 1024. So we have 4 multiplied repeatedly into 5 places. Now I want you to recall that 4 raised to the power minus 5 is the same thing as 1 over 4 raised to the power 5. So we can rewrite this. We can rewrite this using this. Okay? All right. So we have that we're rewriting this equation here as 4 raised to the power x equals 4 raised to the power minus 5. Okay? Now, since their bases are the same, and given that this is an equation, then their powers must be the same. Now you can write that down, it's very important. Since their bases are the same, then their powers must be the same. Therefore, x is equal to minus 5. All right, so for more questions on these exponential equations, follow me on my Instagram page where I release all the questions, where I solved all the questions, and the videos are there. And probably I'm going to put up the videos here too on YouTube. But you can find me on my Instagram handle at onyi_math. Thank you so much. Thank you so much for being with me on this math journey on indices to the end. And please don't forget to turn on your notification bell for my new video alerts. I won't stop teaching math. I will always teach math, okay? So stay tuned and always check up on me to find out the new videos I've released. Thank you for watching.